In this video, I'm going to teach you about how to construct a truth table, but before we get started, let's talk about what a truth table is. First, you need to know what a truth value is. It says the truth value of a statement is the classification of the statement as either true or false, and they're going to use T for true and F for false. Now, we've been learning about compound statements and symbolic logic. And one convenient way of determining whether a compound statement is true or false is to construct a truth table. A truth table, by definition, is a listing of all possible combinations of the individual statement as true or false, along with the resulting truth value of the compound statement. Right, so it's going to be a big table. You're going to start with both of your individual statements, like P and Q. You're going to list out the options for those, true or false. And then you're going to use 4 rules that we're going to learn to classify the resulting compound statements as either true or false. And as we'll be able to see afterwards, truth tables allow us to distinguish valid arguments from invalid arguments. So the first rule of truth tables is negations, and this is also the easiest rule. For negations, you're just going to change T's to F's and F's to T's. Right, so anytime you have a negation, you're just going to use the opposite truth value from what they have in the first column there. Right, so let's look at an example of a negation. So here we have a statement. It says the lyrics are not controversial. Right, so, and then for P, it tells us that P means the lyrics are controversial. So we have 2 things they're asking us to do. Part A says translate the compound statement into symbolic form. All right, so by compound statement, they mean that first line there that says the lyrics are not controversial. All right, so that compound statement is going to be symbolized as not P. The next thing we need to start doing is constructing the truth table for that expression, not P. All right, so here's our blank truth table. We've got P. The 2 possible options for P, or the 2 possible truth values, are true and false. We need to fill in the not P column. Now we know that to fill in the not P column, you're just going to change the T's to F's and change the F's to T's. All right, so T turns to F. F turns to T. So that is the completed truth table for that compound statement. Our next rule deals with conjunctions. Remember, conjunctions are and statements. They're compound statements that are connected by the word and. All right, so here's the rule for conjunctions. All right, so you see now we have P and Q. We have 2 statements that are connected by the word and. All right, so P is always going to be filled out for you. So P is going to be true, true, and then false, false. Now there's 4, the reason they do this is because there's 4 different combinations. You could have P is true and Q is true, P is true and Q is false, P is false and Q is true, and then P is false and Q is false. So those are your 4 possible combinations for P and Q. Next, we're going to look at the very last column, P and Q. And the rule says that P and Q is false unless both are true. So this is a really easy way to remember that. So P and Q is false unless both are true. All right, so let's go back to an example. Here we have an example of a conjunction. The compound statement says, the lyrics are controversial and the music is banned. Statement P is, the lyrics are controversial. Statement Q is, the music is banned. The first thing they ask us to do is to translate the compound statement into symbolic form. And they're referring to the statement, the lyrics are controversial and the music is banned. So if you translated that into symbolic form using P and Q, that would be the lyrics are controversial is P, The music is banned is Q. So that would be P and Q. Next, we need to construct a truth table for this expression. So here we have our blank truth table. We need to start by filling in the options for Q. Now, I just talked about the 4 options for Q, and it's based on the truth value of P. All right, so your first option is you could have true, false. Then you could have true, true, false, true, and false, false. Now we need to use the rule that we learned to construct or to fill in the P and Q column. Now the rule said that it's false unless both are true. Alright, so the only one that's true is the one where it's true, true. The rest of them are false. So it's false unless both are true. Now you have your completed table. Next, we have the rule for disjunctions, or statements. Now, this table sort of looks similar to the one we just saw. The Q is the same. For the P or Q column, we have the following rule. P or Q is true unless both are false. So you can see the only time you have a false in the P or Q column, it's when P is false and Q is false. Otherwise, it's always true. Now let's look at an example. Here's our example on disjunctions. It gives us the compound statement, the animals are sleeping or playing. The statement P is the animals are sleeping. The statement Q is the animals are playing. We're going to start by translating this compound statement into symbolic form. So the animals are sleeping or playing. So that would be P or. Next, let's construct a truth table for the expression P or Q. Here we have our blank truth table. We will start by filling in the column for Q. Now, we've filled in this column several times already, so I'm just going to go ahead and fill it in. Next, I need to fill in my column for this statement P or Q. Now, remember the rule. The rule is for P or Q, it's going to be true unless both are false. So we're going to find the row where it's false, false, and we're going to go ahead and fill that in. Next, let's fill in the rest of the rows. And we're done. This is our completed truth table. The last rule that we need to look at is the rule for conditionals or implications. So here we have the rule for conditionals and implications. It looks like this. It says our first 2 columns are the same as they always have been. But you'll notice that most of the time the implication P implies Q is usually true. The only time that it's false is when you have true implies false. All right, so in that second row we have true implies false, P implies Q. So the only time that you're going to have a false is when you have true implies false. So that's what you want to be looking for. Let's look at one more example. Here's our implications example. It says, if the lyrics are controversial, then the music is banned. So our statement P is the lyrics are controversial, Q is the music is banned. So it says, if the lyrics are controversial, then the music is banned. So it's if P, then Q, or P implies Q. Next, we need to construct our truth table for this expression. Here's our blank truth table. We're going to start by filling in the column for Q. Now that we've got Q filled in, we need to look for where we have true implies false, because we know that row is going to be false. Everything else will be true. All right, so you see it's in the first row there. We have true implies false. We don't have it anywhere else, so we'll go ahead and fill in the last three rows with truths. And now we have our completed truth table. Next, we want to look at an example that puts it all together. Right, so this is specifically putting together negations and implications. So the first thing you want to do is fill in your column for Q. So I filled in my column for Q the same way that I've done it before. Now we can move on to the next column. The next column is the not P column. So when you're looking at the not P column, you want to make sure and relate it to the P column. Right, so if it's true, it's going to become false. Here again, we have a true that becomes false. Next, we have a false that becomes true, and then a false that becomes true. Now let's move on to the not Q column. We're looking at Q, so the false becomes true, the true becomes false, the true becomes false, and the false becomes true. Now we'll look at our last column. Not P implies not Q. This time we're going to be focusing on the two rows the two columns that I have circled here. And remember, the rule for implications is that it's going to be true most of the time. The only time it's false is when you have true implies false. So you want to locate that spot first. All right, so don't forget that rule. So here we have true implies false, and we know that that's going to make it false. Everything else is true. So here's our completed truth table where we put it all together.